This is my trigonometry course. Today you're going to prepare for the 4th test of the course. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. I've said it before, I'll say it again. There are some subjects where you can study the night before and get a perfect score in the exam. Math doesn't work that way. You need at least 2, 3, maybe even 4 days to prepare for a test. But it doesn't matter how many times you tell students to study for an exam, they're not going to do it. So in order to force you to do at least some studying, we're going to do a practice test right now together. And I'm going to give you a practice test for homework as usual. And these tests are not only going to force you to do some studying, but they're also going to familiarize you with the format of the test. Here are some things that you have to remember. You're going to be expected to have these memorized. So take note of that. They're not all the things that you need to memorize, but that's most of the new stuff that we covered in the last 2-3 weeks. You're going to need a calculator, and whenever you need to use pi, do not use 3.14. Use the pi button on your calculator. So you need to know how to use the pi button on your calculator. So let's start the first practice test, and I want you to try these problems on your own. See if you can do them on your own. If you can't, that's okay. You may be a little rusty, but attempt part 1 of the first problem here. See if you can do it, and when you come back, we'll do the problem together. Okay, we're back. So to convert from degrees to radians, we multiply by this conversion factor. And remember, you don't have to write units for radians in most cases. So we get 50 pi over 180. The degrees cancel out. We can divide both sides of that fraction by 10, and we get 5 pi over 18. Again, you don't have to write rad. You can if you want to, but it's not really required. Radians don't, you don't need to write the units for radians. So if you got that right, good job. Try part 2, and when you come back, we'll do it together. Okay, we're back. So when you convert to degrees, you multiply by the same conversion factor, except you flip it. And the pi's cancel out. I guess we can write what that would be. So 6 times 180 is 1080 degrees. The pi's cancel out, and you're left with 1080 degrees. So if you got that right, excellent. Be sure to write your degree symbol, signifying that we're now in degree units. If you don't see units, that means we're in radians. Okay, go ahead and try part 1 of problem number 2. You need to do this without a calculator. And when you come back, we'll do it together. Okay, we're back. So pi over 2 is 90 degrees. If you want, you can go ahead and convert that. It's kind of hard to interpret pi over 2. So we can convert that to degrees, and we get 180 pi over 2 pi. The pi's cancel out, and we're left with 90 degrees. And you get 180 pi over 2 pi. The pi's cancel out, and you're left with 90 degrees. And so what we're really looking for is cosecant of a 90-degree angle. And that's a collapsed triangle, so we're going to go to our curve. Whenever you have a collapsed triangle, you want to use these curves. So we're going to go out 90 degrees, and that means that our y value is going to be 1. So if x is 90 degrees, y is 1. So cosecant 90 degrees is equal to 1. Okay, if you got that right, perfect. Try part 2, and when you come back, we'll do it together. Okay, we're back. So pi over 4 is 45 degrees. If you can remember that, then all you have to do is multiply 45 degrees by 5, and we see it's going to be negative 225. But if you don't want to do it that way, you can convert from radians to degrees. And by the way, the reason we know that these expressions are in radian units is because there is no degree symbol. So 5 pi times 180 is 900 pi, and 4 times pi is 4 pi. The pi's cancel out, of course, and 900 divided by 4 is 225. So now what we're really looking for is tangent of a negative 225 degree angle, and that's going to be a triangle in the second quadrant. So that's our angle there, and our reference angle is going to be 45 degrees, of course. So we have our green reference angle, it's 45 degrees, and our red reference angle is negative 225. And our sides are x, negative x, and x root 2. So tangent negative 225, that would be the opposite side of the green reference angle divided by the adjacent side of the green reference angle. So that would be negative 1. So we got that right. Excellent. Okay, go ahead and try number 3. Now there's two ways you can do this. One way is you can convert pi over 5 to degree units, or you can change your calculator to radian mode and then calculate cosine pi over 5 directly. Try number 3. When you come back, we'll do it together. Okay, we're back. I'm going to change my calculator to radian mode. So press the mode button if you're using a TI calculator, Texas Instruments. Use the arrow keys to go down to radians, press enter, then push the blue button at the upper left, and then the mode button to quit out of that screen. And then we're going to press cosine and the pi button. In order to find the pi button on a Texas Instruments, you're going to push the blue button at the upper left, and then the upside down V button at the upper right. And you should see a pi symbol, and divided by 5, and then enter. Now, if you're using an iPhone, you want to rotate in landscape mode, and at the bottom left, push the rad button, and you want it to say DEG. If it says DEG, you're in radian mode. And of course, you want to enter pi over 5 first, and be sure to use the pi button. You do have a pi button on your iPhone. Okay, if you got that one right, good job. Try number 4. Be sure to write your answer in radian units, and when you come back, we'll do it together. Okay, we're back. I'm going to subtract secant theta from both sides of the equation, and I'm going to add 3 to both sides of the equation, and then divide. Well, maybe I should do this in steps just in case anybody gets confused. Then we're going to divide both sides by 6, and we see that secant theta is equal to negative 1. But this represents a collapsed triangle. So remember, when secant, cosine, cosecant, or sine are equal to 1 or negative 1, or in the case of sine or cosine 0, then you have a collapsed triangle. And if cotangent or tangent is equal to 0, you have a collapsed triangle. So secant is equal to negative 1. So look at the points on the red graph that have y values that are equal to -1. And that would be these points here. But we only care about the points that are between 0 and 360 degrees, or 0 and 2 pi if you're using radian units, so that's going to be here. So the x value is 180. So theta is equal to 180. That's the only value between 0 and 2 pi. But we're supposed to write our answer in radian units. So I'm going to multiply by pi over 180 degrees, and we see that 180 degrees is the same thing as pi radians. So there you go. So if you got that right, good. If you're a little rusty on these problems, that's okay. Alright, find the area of a sector of a circle with radius 7 miles and central angle 2 pi over 5. Notice that there's no degree symbol, so that's assumed to be radians. Try number 5. When you come back, we'll do it together. Okay, we're back. You need your formula. I'm going to give you one more chance to take a picture of all this stuff. We're using this formula here. And so that formula is going to be theta over 2 times the radius squared. Theta, we're told, is 2 pi over 5. And the radius, we're told, is 7 squared. This is a complex fraction. There's a lot of ways to simplify that, but by now you should have a pretty good idea how to do that. The easiest way is to multiply both sides of the fraction by 5. The 5 cancels out here. When you multiply that 2 pi over 5 by 5, you get 2 pi. And when you multiply the bottom by 5, of course, you get 10. 7 squared is 49. And we can reduce that fraction. That becomes pi over 5 times 49. And our final answer is 49 pi over 5. So we don't have to worry about rounding off because we can just write that exact answer. But if you don't write units, that's going to be a problem. It says find the area. So the area is going to be square miles. How do I know it's miles? Well, because the radius is in linear units of miles. So if you got that one right, excellent. Okay, go ahead and try number 6, and when you come back, we'll do it together. Okay, we're back. If you had a little trouble with this, that's okay. The first step is to find the angular velocity, and we know the linear velocity of the Martian at that's farther out from the center. We have this formula here. We know the linear velocity of the Martian man at that's 23 feet from the center. He's going 8 feet per second. And again, he's 23 feet from the center. So the angular velocity of that flying saucer is 8 over 23, and we have to write units. That's going to be radians per second. It's always radians per second if no units are really given in terms of angle. So now we're going to find the linear velocity of the Martian man that is closer to the center. So that's going to be this radius, the distance from the center to the second Martian man, times the angular momentum, which we already found. So that's 10 times 8 over 23, which is 80 over 23. And you don't really have to, but we can change that to a mixed number to make the number more friendly. So units are feet per second. So that is his linear velocity. So if you got that right, excellent. And by the way, this is an answer, so you got to rectangle that also. There's two answers. They're looking for two answers in that problem. Okay, try number 7. And when you come back, we'll do it together. All right, we're back. So they're looking for linear velocity. They give us the angular velocity. So you don't have to break this problem into 2 parts, but I'm going to do it. So there's 4 laps in 27 minutes. That is the angular velocity. But let's change it into a unit that's more familiar to us. A lap is the same thing as a revolution. So now we have RPMs, revolutions per minute. 4/27th of a revolution per minute. So now we're going to convert from revolutions per minute to radians per second. So first let's convert to radians. 1 revolution is 2 pi radians. And again, you can write that rad if you want. You don't have to. And so the revolutions cancel out. And there's 1 minute for every 60 seconds. And you can see that the minutes cancel out now. So if we multiply straight across, we're left with 8 pi radians over 1,620 seconds. So if we divide both sides by 4, both sides of the fraction by 4, we get 2 pi radians over 405, or 2 pi over 405 radians per second. Let's move everything over a little bit so we can write the units. So rads per second. So again, you don't have to write rads, but it's a lot easier than writing s to the negative 1 power or 1 over s. Okay, so now we have the angular velocity. Now we can go on to step 3. Her linear velocity is equal to the radius of the track times omega, and we cannot use omega unless we have radians, and because our answer should be meters per second, we need the angular velocity in radians per second, so that's why we did all that. So the radius of the track is 31 meters, and the angular velocity is what we found in the previous step. That's 2 pi over 405. And we get 62 pi over 405. And that is meters per second. So that's the answer. The problem doesn't tell us to round off, so we can leave the answer in that form. So if you got that right, good. Try number 8, and when you come back, we'll do it together. All right, we're back. So they give us an angular velocity, but we can't use this angular velocity. We can't use RPMs in our equations that we derived in previous classes. So 45 RPMs is the same thing as 45 revolutions for every 1 minute, revolutions per minute. but we're going to convert that to radians per minute, and I guess I can do that in one step here. So 1 revolution is 2 pi radians. So we get 90 pi radians per minute. The revolutions canceled out. So now we can find the linear velocity, but before we do that, maybe we should show that the radius of a circle is equal to the diameter divided by 2. We're given the diameter. So 24 divided by 2 is 12 inches. And now we can use our equation. The radius is 12 inches. The angular velocity is 90 times pi. So 90 times 12 is 1080. And our units are inches per minute. So if you got that answer, excellent. Okay, so let's try number 9. Go and attempt number 9, and when you come back, we'll do it together. Alright, we're back. So they give us the angular velocity. We have 1 rotation every 1.2 seconds. That's the same thing as 1 revolution every 1.2 seconds. Revolutions are more familiar to us. But if we're going to find the linear velocity of the child, we need our angular velocity in radians per unit time. So I'm going to go ahead and multiply, as we did in the previous problem. 1 revolution is 2 pi radians. The revolutions are going to cancel out, and we're going to be left with radians per second. So we have 2 pi over 1.2 seconds, 2 pi radians over 1.2 seconds. Now we could use our calculators to find this in decimal form, or just crunch those numbers, but it's probably best to leave them for now so we don't have round off error. So now we have the angular velocity in the units that we want. So now we're going to use our equation. The radius of the circular motion is 2, because the child rides 2 meters from the center. And the angular velocity is 2 pi over 1.2. So we can simplify that to 4 pi over 1.2 if you want. So 4 times pi in the calculator, enter, and then divided by 1.2, and we get 10.47, says round to the nearest hundredth, meters per second. So if you got that right, excellent. So go ahead and try number 10. Now make sure your calculator is in degree mode. Remember, we switched to radian mode. So go back to degree mode and try part 1 of number 10, and when you come back, we'll do it together. Alright, we're back. So we have the lengths of two sides of a triangle and the angle measure between them. In that case, we're going to use this special formula for the area of the triangle. There are three different versions depending on what corner of the triangle we have. We're going to use this version. And we can enter that into our calculator. And we get 36.25 approximately. 36.25 square centimeters. Be sure to write your units or else you're going to lose points on the test. Have you got that right? Excellent. Okay, try part 2. Again, you're going to round off to nearest hundredth place. When you come back, we'll do it together. Okay, we're back. So when you have all three side lengths of a triangle and no angle measures, you want to use Heron's formula. To use his formula, we have to have the perimeter of the triangle divided by 2. And so if we do that in the calculator, 3 plus 6.5 plus 4, and then divided by 2, we get 6.75. So now we can use Heron's formula. The area of a triangle is equal to S times S minus A times S minus B times S minus C. And S is that number that we found. A is one of the sides, I'll just make it 3. B is another one of the sides, I'll make that 6.5. And C is the remaining side. So 6.75 minus 4. And that's it. All we have to do is calculate and we'll have our answer. So let's simplify a little bit more. We have 3.75 and 0.25 and 2.75. That'll make it easier to enter into the calculator. So 6.75 times 3.75, enter, times 0.25, enter, times 2.75, enter. And then you're going to square root that number. So you can just push this button in the iPhone, or you can press the second button and then the x squared button, and it should say square root on your graphing calculator. So we get 4.17, and make sure that you write your units. We're finding the area of the triangle, so it's going to be square feet. So if you got that one right, excellent. Okay, go ahead and try number 11, and when you come back, we'll do it together. Alright, we're back. So remember, we can use this triangle, or we can use this triangle over here. I'm going to use the upper triangle because the angle 29 degrees is already in that triangle, so to speak. Remember, this height over here is the same as this height. So that is 13 meters. And we're looking for this distance down here, which is the same as this distance up here. So we can just say that that is x. So tangent 29 degrees is the side opposite the angle divided by the side adjacent. Now you don't have to show all this mathematics. but we're going to multiply both sides of the equation by x. Students typically have a lot of trouble solving these simple equations. There's a lot of different ways to do it, and students tend to get confused. Now we can divide both sides by tangent 29, and we'll have an expression that represents our answer. Again, you don't have to show all these steps. You do have to show a little bit of work, but you don't have to show every step like I'm doing here. So our answer is whatever 13 divided by tangent 29 degrees is. So again, make sure your calculator is in degree mode. 13 divided by tangent 29 is 23.45, and it says round off to the nearest hundredth. So 23.45, and the units are meters. So if you got that one right, excellent. Go ahead and try number 12. When you come back, we'll do it together. Okay, we're back. So this is not a special angle, which means we're going to need to use the calculator, but our calculators don't have a cotangent button, so we have to use a reciprocal identity. And now we can use the calculator. 1 divided by tangent 56 is approximately 0.676745, and it says to round off to the nearest 10,000th. So make sure that you do that. If you got that one right, good. Try part 2. 3 is not a recognizable ratio, so we have to use the calculators, but our calculators don't have a secant inverse button. So see if you can do that problem. If you forgot how to, that's okay, but attempt that, and when you come back, we'll do it together. Okay, we're back. So this represents an angle because we have the secant inverse symbol there. So we're going to set it equal to theta in order to help us understand what the problem is even asking in the first place. That notation is used to find the solution to this equation. So we're really looking for the angle that you can plug in to that equation to give us 3. But again, we don't have this button in our calculator, so what we can do is we can use a reciprocal identity. Secant theta is 1 over cosine theta, and you can just flip both sides, and cosine theta is equal to 1/3. So you don't really have to show this. If secant theta is equal to 3, in order to find cosine theta, you just flip and it becomes 1/3. That's something that you're going to need to memorize, because as you go into upper mathematics, you're just going to be expected to be able to do that very quickly in your head. So the benefit of this is now we can use our calculator because we do have a cosine inverse button. Although we did not have a secant inverse button, we have a cosine inverse button. So push the blue button at the upper left if you're using a TI-84, and then 1 divided by 3, and then enter. Now if your calculator is in degree mode, which it should be, then you should get 70. It says nearest 10,000, so 70.5288 degrees. And that is the answer. So we got that right. Excellent. And that is within our domain, or our range restrictions, that is. The secant function can be between 0 and 180 degrees, not including 90 degrees. Okay, go ahead and try number 13. And when you come back, we'll do it together. Alright, we're back. So in case you forgot, arc sine is the same thing as sine inverse. And so in order to figure out what that is, we're going to set the expression equal to theta, because we do know it's an angle. That notation always signifies an angle. And that's the notation we use in our calculators to solve this equation. So we're really looking for the angle that would make this equation true. And so sine is negative in the third and fourth quadrants. So I'll be down here and down here. And maybe I'll write this over here so we have more space. And we recognize this ratio as a 45, 45, 90 degree ratio. You don't have to write all the sides, but it helps us to understand what triangle it is. Our reference angles are 45 degrees, so our first angle is 225 degrees. And our second angle, which we can make a blue color, I guess, that'll be 315 degrees. Now we're looking for the value of this expression here. We're not really looking for all of the answers to this equation, because there's an infinite number of solutions. We're just looking for the value of this expression, which is considered to be the output of a function. So you're only allowed one number. And there are restrictions as to which numbers you're allowed. Remember, the sine inverse graph is restricted to numbers between negative 90 degrees and 90 degrees, and neither of these answers are between negative 90 and 90. So what do? You get to the closest number, and you rotate clockwise instead of counterclockwise, and that gives us a negative angle. That is negative 45 degrees. So the answer we're looking for is actually negative 45 degrees. So our final answer we can write as arc sine of negative 1 over root 2 is equal to negative 45 degrees. So if you got that right, excellent. Okay, on to the next one. See if you can do number 14. When you come back, we'll do it together. All right, we're back. So we can't use a calculator here, but we don't recognize this ratio. So we're kind of stuck. But if we multiply both sides of this fraction by root 3, so what we're doing is we're rationalizing the denominator. Sometimes you're not going to be rationalizing the denominator. Basically, you just want to multiply both sides by the root, whatever the root is. That's going to change the form of the ratio. So now we get 3 root 3 over root 9, and root 9 is 3, and you can see where this is going. So we have 3 root 3 over 3, and that reduces to root 3. Now this is a ratio that we recognize. It's x root 3 over x, and cotangent is negative in the second and fourth quadrants, and cotangent b is the adjacent side divided by the opposite side. And the angle opposite x is always 30 degrees, so we have a 30-degree reference angle. But the actual angles that we're looking for are 150 degrees and 330 degrees. says find the solutions between 0 and 2 pi. That's 0 and 360. So we have our solutions. B can be equal to 150 degrees or 330 degrees, but those numbers are not in radian units. We have to write our answers in radian units. Between 0 and 2 pi, so I'm going to multiply by pi over 180 degrees so we can convert to radians. And then we're going to have to reduce the fractions. I can write these down a little lower. So all we have to do is reduce those fractions, and then we'll be done with this problem. So we get 150 pi over 180, or 330 pi over 180. And divide both sides by 10, and we get 15 pi over 18. Then divide both sides by 3, and we get 5 pi over 6. Divide both sides by 3, and we get 11 pi over, actually first let's divide both sides of the fraction by 10. You can do it in one step by dividing both sides by 30, but it might be easier for some students to do it in steps. Then divide both sides by 3, and we get 11 pi over 6. So if you got that right, good. Now try number 15, and when you come back, we'll do it together. Alright, we're back. So I'm going to simplify the equation. Two apples minus 5 apples is negative 3 apples, even though you can't really have a negative apple. Then we're going to divide both sides by negative 3. And in order to find beta, we have to use a calculator because this is not a recognizable ratio. The problem is we don't have a cosecant inverse button in our calculators, so we're stuck. We can't do anything. But remember, cosecant beta is the same thing as 1 over sine beta. And if we flip both sides, again, there's a lot of different ways to do this. You could cross multiply, a lot of different ways, but really all you have to do is memorize the fact that if cosecant beta is the reciprocal of sine beta, so you can just flip the fraction. So now we can use the calculator to find the angle, because our calculators do have that number. So sine inverse of 3 over 10 is 17, approximately. 17.4576. It says round to the nearest hundredth. Now it says find the solutions between 0 and 360. So in this case we do have the reference angle. Sometimes our calculator is not going to give us the reference angle, but this time it did. Now sine is positive in the first and second quadrants. So the reference angles are 17.45 degrees approximately. So we have this angle, and then we have this angle, which is 180 minus that number. That'd be 162.54 roughly. Keep these numbers in your calculator. So beta can be 17.45, actually 46 if we round up. Again, it says round to the nearest hundredth. or it can be 162.54. So there you go. If you got those solutions, excellent. Okay, go ahead and try number 16, and when you come back, we'll do it together. Alright, so now we're doing these composite expressions. Remember, the most important thing is to start an inside part. Start by analyzing the inside part. Find what that yellow value is, and then you can find sine of that value. So try number 16. When you come back, we'll do it together. Alright, we're back. So the inside part is going to be an angle, but we don't know what angle it's going to be. So I'm going to set it equal to theta. And that notation is used when you're trying to solve this equation. So we know that we're just looking for that angle. Again, the reason we converted from this form to this form is to just understand what we're looking for, because this yellow notation is very confusing. So now we can draw triangles. Cosine is positive in the first quadrant and the fourth quadrant. And this is obviously a 30, 60, 90 degree triangle. And the angle opposite x root 3 is always 60 degrees. So that's the reference angle. So one of our angles is 60 degrees. And the other angle would be 300 degrees. But remember, this notation is considered to be the output of a function. A function can only have one output for every one input. In this case, 1/2 is the input. And so we have to look at the cosine inverse range restrictions, and it's restricted to 0, numbers between 0 and 180. If you look at this. So those are your range restrictions. So we have to pick a number. We can't just use any of those numbers. So we're going to pick 60 degrees because that's within the range restriction. So now we know that cosine inverse of 1/2 is equal to 60 degrees. Well, now we can go on to part 2 of the problem. So that was part 1, find the inside. Part 2 is to find the final solution. So we know that cosine inverse of 1/2 is 60 degrees. Now we just have to find sine 60 degrees. Well, that angle is in the first quadrant. And obviously it's a 60, 30, 90 degree triangle. Sine 60 is the opposite side divided by the hypotenuse. So that would be root 3 over 2. And there you go. So if you got that one right, excellent. So go ahead and try number 17. And when you come back, we'll do it together. Alright, we're back. So as usual, we're going to start by finding the value of the inside expression. But we don't know what that notation means, so we're going to translate to a different form, or convert to a different form, and cotangent is negative in the third and fourth quadrants. And we're dealing with 45, 45, 90 degree triangles. The reference angles are both 45 degrees. And so one angle is 135 degrees and the other angle is 315 degrees. And if you look at the range restrictions for cotangent inverse x, the restrictions are between 0 and 180 degrees. So we can use 135 degrees. So theta is going to be 135 degrees. So that is part 1. To find the value of the inside expression. So now we're going to find cosecant of cotangent inverse of -1. We know cotangent inverse of -1 is 135. We just found that. So now we just need to find cosecant 135 degrees. And we're kind of just drawing the same triangle that we did up here. We could actually just use this triangle, really. So obviously this is a 45, 45, 90 degree triangle. And we want cosecant 135 degrees. That's going to be the hypotenuse over the opposite side. So x root 2 over x, which is just going to be root 2. So if you got that one right, excellent. Okay, let's go on to the next problem. Try number 18. When you come back, we'll do it together. Alright, we're back. So again, remember, most important thing is to start with the inside expression, but we don't know what the inside expression is even asking us to do, so we have to convert, and now we see we're just looking for that angle. Cosecant is negative in the third and fourth quadrants, and we're dealing with a 45, 45, 90 degree triangle. So you don't have to write all these sides. You don't have to even draw this picture if you don't want to. But we're just demonstrating using the picture. So we have one angle that's 225 degrees and another angle that is 315 degrees. But neither of those angles are going to work because they're not within the range restrictions for the cosecant inverse expression. This is considered to be the output of a function. A function can only have one output for every input. So the angle that we're looking for is going to be -45, which is coterminal with 315 degrees. So -45, that's what cosecant inverse of -√2 is equal to, -45 degrees. So now we're going on to part 2. We're going to find tangent of cosecant inverse of -√2. Now we just found the inner part is -45 degrees, and so if it's a negative angle, then we're going to rotate in the clockwise direction, and our reference angle is 45 degrees. And of course our sides are -x and x√2. And tangent is the opposite side of the green reference angle divided by the side adjacent to the green reference angle, so that would be -1. So if you got that right, excellent. Okay, on to number 19. Now notice that we have functions that are inverses of each other. Something very important to understand is when the inverse function is on the inside, the answer is just going to be whatever that expression is. So I guess I just gave you the answer. Now you could prove that by doing things the same way we did over here, but it's not really necessary given that we know the answer is going to be 2 over root 3. Now that's only that's true if the inverse function is on the inside and the normal function is on the outside. If the inverse function is on the outside, then you have to be careful because the solution is not always going to be this value. So be aware of that. We'll get to some of those problems later on. Try number 20. Remember, the triangles that we're going to be talking about are in the first quadrant for these problems. How do I know that? Well, because x is positive. And in this particular problem, that means that our triangles are going to be either in the first or the fourth quadrants. But cosine inverse has range restrictions, so it's only allowed to be in the first or second quadrants. So it's not possible to be in the fourth quadrant. That leaves the first quadrant. So the triangle must be in the first quadrant. That's the way it is with all of these problems with variables. So try number 20. When you come back, we'll do it together. Okay, we're back. So as in the other problems, we're going to start on the inside part of the composite function. And we're going to convert. And that's the same thing as saying that cosine theta is x over 1. So now we're going to draw a triangle, and again the triangle is going to be in the first quadrant. And cosine is adjacent over hypotenuse, and now we just have to find the length of that side. Because we're trying to find cotangent of that angle, which requires the opposite side of the reference angle. And by the way, we should write the reference angle, that's theta. So we have to use the Pythagorean theorem. We'll just plug everything in. Whoops, that should be b. Hypotenuse is 1. And we're trying to solve for b. And you don't have to show every step of this. Square root both sides, and we get plus or minus 1 minus x squared. Now, you tell me, is b going to be positive or negative? You can tell just by looking at the triangle. Obviously, b is going to be positive because this side is above the x-axis. So b is actually positive root 1 minus x squared. So we can write that in the triangle. Positive square root 1 minus x squared. And now well, we can say that that's part 1. And part 2 is to find cotangent of cosine inverse of x. But that's the same thing as asking for cotangent theta, because remember, we define that to be theta. But theta is here. So all we have to do is look at the triangle, we have our answer. Cotangent is the adjacent side over the opposite side of the green reference angle. And we have our answer. Now, because we're dealing with variables here, we don't want to complicate things and have to rationalize the denominator, so you can leave the root in the denominator. That's completely fine. So if you got that right, good. Okay, try number 21. Without a calculator, you're going to start by analyzing the inside. Find the value of the inside expression first. That's the most important thing to remember when dealing with composite trigonometric functions. So try 21, and when you come back, we'll do it together. Okay, we're back. So part 1 is to find the value of cotangent 120 degrees. So that's going to be a triangle in the second quadrant. The reference angle is 60 degrees. And so that means this side is going to be x root 3. This side's 2x. This side is negative x. Cotangent is the adjacent side of the green reference angle divided by the opposite side. So we have negative 1 over root 3. Now we're in the intermediate step of the problem, so we don't really have to rationalize that denominator. So now we're going to find tangent inverse of negative 1 over root 3. But we don't know what this means. So we're going to have to set it equal to an angle, because we do know that it is an angle that we're looking for. That's what that notation refers to. And then we're going to convert the form of that equation, and now we can see what we're actually looking for. So now we can draw triangles in the second and fourth quadrants, because tangent is negative in the second and fourth quadrants. And the sides are going to be x, negative x, x root 3, and negative x root 3, and 2x and 2x. The angle opposite x is always 30 degrees, so that's the reference angle. And the angles we're looking for are 150 degrees and 330 degrees. But neither of those angles works. Tangent inverse has range restrictions. It can only be between negative 90 degrees and 90 degrees. So we have to rotate in the clockwise direction. And the answer we're actually looking for is negative 30 degrees. That's the range restrictions that mathematicians have put on the tangent inverse function. So the theta value that we're looking for is actually negative 30 degrees. And that's it. We're pretty much done. Tangent inverse of cotangent 120 degrees is equal to negative 30 degrees. Now, why is there only one solution? Because the function is the tangent inverse function. We're just putting an input into it, and the tangent inverse function, again, has range restrictions. We're only allowed one number. This is considered to be the output of a function given some input. The input, in this case, being cotangent 120. So if you got that right, excellent. Okay, so now we have functions that are inverses of each other, and the inverse function is on the outside, which means that you have to be careful. The answer is not going to be 315 degrees. I know that because this is outside of the sine inverse range restrictions. So you're going to have to do this problem step by step. First find sine 315 degrees, and then proceed from there. Try number 22, part 1, and when you come back, we'll do it together. Alright, we're back. So we're going to start by finding the value of the inside part of the composite function. And that's a triangle in the fourth quadrant. The sides are negative x, x, and x root 2. The reference angle is 45 degrees, of course, and the actual angle is 315. Sorry about my writing. And so sine is the opposite side of the green reference angle divided by the hypotenuse. So sine 315 degrees is equal to negative 1 over root 2. Okay, so now we go on to the second part of the problem. We're going to find sine inverse of sine 315 degrees. Now we just found that sine 315 degrees is negative 1 over root 2. So now we proceed from there. Now this is notation signifying an angle. But what angle are we looking for? So we're going to have to set that equal to theta. And then translate to a different form. And sine is negative in the third and fourth quadrants. Whoops. And so we have 45, 45, 90 triangles, obviously. Reference angles are 45 degrees. And one angle is 225 degrees. And the other angle is 315 degrees. But neither of those angles are within the sine inverse range restrictions. So we have to rotate in the other direction, the clockwise direction, and we see that the number we're looking for is actually negative 45 degrees. So theta is actually going to be negative 45 degrees. So that's the value that we're looking for. So now we can say that sine inverse of sine 315 degrees is negative 45 degrees. So there you go. I'm going to put a divider here. So if you got that right, good. Go ahead and try this problem here. Now, again, we have functions that are inverses of each other, so the question is the answer going to be pi over 2? To know what it's going to be, we ask ourselves, is pi over 2 within the range restrictions of the cotangent inverse function? And it turns out that it actually is. If you look at that restriction, it's between 0 and 180 degrees. So we could go through the motions as we did in the previous problem, but we don't really need to. It's just going to be pi over 2, so that'll save you a lot of time if you can remember that. Okay, go ahead and try number 23, and when you come back, we'll do it together. Okay, we're back. So again, we're going to start by analyzing the inside part. And pi over 3 is 60. 60 times 2 is 120. So that is one way to figure out what that angle is, but you can also use your conversion factor. We'll get 360 over 3, which is 120 degrees. So you can do it that way also. But now that we know it's 60 degrees, let's go ahead and, or excuse me, it's 120 degrees. Let's change it to that because it's easier to recognize, easier to work with degree measures. So our triangle is going to be in the second quadrant. And our reference angle, of course, is a 60-degree angle. And our sides are going to be x root 3, negative x, and 2s, because it's a 30, 60, 90-degree triangle. Cosecant is defined as the hypotenuse divided by the opposite side, so that's going to be 2 over root 3. So, there you go. Now we're in the intermediate step, so we can leave the ratio in that form. Let's go on to step 2. We're going to find secant inverse of cosecant, 2 pi over 3. But we just found the inside part. That's 2 over root 3, so we already did that. Whoops. Let's remember to write our inverse symbol. Now, secant inverse is an angle. But how do we know what the angle is? Well, we'll set it equal to theta, and then we'll convert the form of the equation, as we always do. And now we see what angle we're looking for. So let's draw a triangle. Secant is in the, it's positive. So our triangles are going to be in the first and fourth quadrants. So first and fourth quadrants. The hypotenuse is 2x. And the adjacent side is x root 3, because secant is always hypotenuse over adjacent. And the opposite side is going to be x, so the angle opposite x is always 30 degrees. So our reference angle is 30 degrees. This angle would be 330, but secant inverse has to be between 0 and 180, so theta is actually going to be 30 degrees. So we found the answer. So let's write the final form of the answer. Secant inverse of cosecant of 2 pi over 3 is equal to 30 degrees. So there you go. If you got that one right, excellent. Okay, so we have a couple more problems here. It says, well, you can attempt this one on your own. See what you can do. And when you come back, we'll do it together. Alright, we're back. So, let's draw some segments here. A GPS device shows that a plane must fly 231 kilometers on a bearing 19 degrees south of west. So that would be something like that. The angle doesn't have to be exact. And so that's 19 degrees. And that's to get to Oakdale. The device also shows that the same plane must fly 150 kilometers on a bearing 59 degrees south of east. So that's about here, maybe. 59 degrees. And they want to know how far apart the airports are. So it's kind of hard to write all of this stuff, but we can say that this length here is 231, and this other length is 150. It's kind of sloppy there. So maybe we can just hold off on the lengths until we pull the triangle out. So let's pull the triangle out just so we can get a feel for what we're dealing with here. And the triangle doesn't have to be exact. That's not really the point. But this length is 231, and this length over here is 150. Now we have to find this angle here. In order to do that, we're going to subtract 19 from 180 and also 59, and we get 102 degrees. So this angle here is 102 degrees. And we'll call this missing side X. So you see we have the lengths of two sides of a triangle and the measure of an angle between the two lengths. So we can use the law of cosines. And if you want, we can write that. There's three versions. They're all pretty much the same thing, just depending on how you label the triangle. But we'll use C for X. And so we're going to plug in numbers. Whoops. We need a 2 there. I'm going to bring this to the left a little bit. So all we have to do is simplify this. And to be honest with you, you don't really have to show any of the work. You just have to plug everything in and then do the calculations on your calculator, because this is going to be kind of a nightmare to have to write all that down. But we'll do that just so you can see what's going on. And 2 times 231, and then times 150. That's going to be 69,300 times cosine 102. So 69,000 times 69,300 times cosine 102. We get that number, and that's going to be a double negative. So that is some big number. And you want to keep that in your calculator. And make sure that it turns to positive. Because we have a double negative. Again, you don't have to write all this out. You can do a lot of it in your calculator without having to show it. So we're going to add all these numbers together. And we get approximately 90,269.28. And then you're going to square root both sides of the equation. And you should know how to do that in your calculator by now. On the iPhone, it's going to be something like this. And on the TI-84 Plus, you're going to press the blue button and then the X squared button, which gives you the square root button. And we get 300. And it doesn't tell us what to round off to, so we can just say 300 kilometers. So that's our answer. So if you got that one right, good job. Go ahead and try number 25, and when you come back, we'll do it together. Okay, we're back. So first, let's draw that thin triangle. And we'll call this corner B and this corner C, and this length is 4. And the measure of angle A is going to be 26 degrees minus 20 degrees. And we can find the measure of angle B by looking at our picture up there. The measure of angle B is going to be 180 degrees minus 26 degrees, and then minus 90 degrees. So how do we know that? Because if we look at this this big triangle here, we know that this angle is 90 and this angle is 26. So if we subtract 26 and 90 from 180, we get this upper angle here, which is B. So 180 minus 26 minus 90 is 64 degrees. So we can write that in. And this angle, again, angle A is 6 degrees. So now we have an AAS situation, angle side scenario. Sine A over A is equal to sine B over B. That's the law of sines. So we have sine 6 degrees over 4 is equal to sine 64 degrees over B. And B is this yellow distance. I'm not going to show all the steps because you've seen these steps many, many times. It's just the same algorithm to solve this. And so now let's go to the calculator. Make sure you're in degree mode. 4 times sine 64, enter. And then divided by sine 6, enter. We get 34.394. And you want to keep that number in your calculator. So now on to step 2. We're now going to look at this smaller triangle here. So let's draw that smaller triangle. We'll call this side X, so that represents this length here. And of course this angle would be 20 degrees. And we know this yellow length up here, that's the same yellow that you see at the left. That's 34.394. And again, you want to keep that number in your calculator. So now we can say sine 20 degrees, and by the way, this is A, this corner is B, and we can't call this corner C. It's not C because C is up here. We want this corner here, which we can call D. So sine 20 is equal to X over 34.394. Multiply both sides of the equation by 34.394, and we get 34.394 times sine 20 degrees. That's X. That should probably be an approximately equal to sign just to make things exact. So you should have this number in your calculator. So you just want to enter times sine 20 and then enter, and we see that X is approximately equal to 11.7635. Now you want to keep that number in your calculator also. Now a lot of students at this point would say, well, we're done. We've found our answer, but we have not actually found the answer. We found this distance here. That's not what we're looking for. We're looking for the pink distance here. So we have to add the man's height, 5 1/4 feet. So we can call that part 3 if you want. The man's height is approximately equal to X plus, or not the man's height, but the bird's height from the ground is 5 1/4 plus X. So that's 11.7635 plus 5 1/4. And you should have this number still in your calculator. So we're going to add 5.25. That's the easiest way to enter that into your calculator. So the height is approximately equal to 17.01 feet. If you got that answer, Excellent. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3 and number 4 and number 5, number 6, 7, 8, 9, 10, and 11. But don't go before you get your homework. The homework is another practice test, version 2. Here's screenshot number 1 and number 2 and number 3, number 4, 5, 6, 7, 8, 9, and 10. But don't go before you get the answers. Remember, it's not enough to attempt the homework. You have to do it completely and correctly. So here's the answers. Make sure that you get all the right answers. And so remember, that practice test is the absolute minimum that you need to prepare for the test. So get that practice test done, and I'll look forward to seeing you in the next class.